So this video is going to show you how to convert a binary numbers to decimal numbers. So binary is the number base, right? That has only 0 and 1, so that's why you see is 1001, which is a computer language. And decimal number is the number that we count, which is human language here, right? So for example, how do we get to 169? So the easier way to look at is if you want to just memorize. We said how many bits are there? 1, 2, 3, 4, 5, 6, 7, 8. I'm going to copy and paste it here, and we give some spaces. Or let me actually put in Excel then. Let me see it. Because Excel have the grids. Then you can see. So what I'm going to do is I'm going to copy that in each columns. 1, 0, 1, 0, 1, 0, 0, 1. And this is a number. Okay. And we said this is going to be equals to 169. So I'm going to say 169. Okay, I put the symbols equals. We pretty much has to format the text here. Otherwise, we not let me say. Let me just type equals then. Now, on the left hand, this is a binary. And on the right hand, this is a decimal. Bold it, make it bigger. Put the grids. So let's study decimal number first. We know this is called ones, right? This is tens. This is hundreds, right? And ones is 10 to the 0. So I'm going to use the correct for exponents to the 0, right? This is going to be 10 to the 1. And this is going to be 10 to the 2. So 10 to 0 is going to give you 1. 10 to 1 give you 10. 10 squared will be 100. So let's look at the binary. This is decimal. That's why it's 10. Right? Decimal is 10. It's 10 different number from 0 to 9. That's why human use it, because human has 10 fingers, 10 numbers. But a computer doesn't have 10 fingers. What the computer has? 2. That's right. 0, 1, which is on and off. So computer has to do just binary numbers. So then that means this is ones in the term of binary, which is 2 to the 0, right? And this is pretty much, this is 1, so this is tens, right? Which is, maybe it's not called cell tens, it could call cell twos. Because it's 2 to the 1, right? And it's going to start to call cell what? 2 to the 2, which is going to call cell 4s. Right? Because 2 fingers, right? So this is going to be 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to to, it's going to keep going, but in this example we have up to 7 bits, right? If it's 8 bits, it's 2 to 8 and so on, and start to do this as 1s, 2s, 4s, right? 8, right? And what, 16s, right? And then 32, right? 64, 128. So 128, right? 100 is, do I have TH here? No, right? Hundreds, right? Okay. Alright, so that's how we have exponents for each own digit. Now, if I want to convert binary to decimals, we know that 100 times 1 is 100, right? And 10 times 6 is, so we pretty much just do multiply here, right? 100 times 1. Or we should say 1 times 100. This is going to be 6 times 10, right? And 9 times 1. And we have 169. So when we add them all up, we get 169. Sure. So that's how we get these answers, right? Now, let's do the binary first. So this is going to be what? 1 times 1, right? 0 times 2, correct? 0 times 4, or 4 times 0, or 0 times 4. Or, and then 1 times 8, 0 times 16, 1 times 32, and 0 times 64, and then 1 times 128. Which we will get 128, 0, 32, 0, 8, 0, 0, and 1. And then we sum them up, right? We add them all. So 32 and 8 is 40. 40 and 128 is 168 plus 1, which is 169. So right, we just sum, right? Sum. So that's how we get this, right? This is the sum. I'm going to say sum. Then we know. Now, for hexadecimal, okay, let's test hexadecimal now. So I'm going to say, what is the hexadecimal of 169? We know that it's easier if we have binary, right? If we convert from binary to hexadecimal, we just do every 4 bits, right? So let's say if we say this is hexadecimal. So hexadecimal is like 16, right? That's 16. So question is, what is a hexadecimal binary? We said we can go every 4 bits. 1001. This is 8 plus 1, which is 9, right? So I get 9. Correct? 8 plus 1 is 9, right? And this is another 4 bits, but it has to be, we don't use this, we use the start over from 1, right? 2 plus what? 8, which is 10, which is A, right? 10 in hexadecimal we said A. So let's review this a little bit from this table. Correct? That's what we use. 0 to 9 and 10 we call A in hexadecimal. And that's why A is 1010, right? And 9 is 1001. So we have 1010 and 1001. That's why A9. Alright. Now let me make sure it's equals to this 2, right? So now we have hexadecimal here. We're gonna do the same. We said hexadecimal also have what? 16 to the 0, right? And then this is going to be 16 to the 1. And this is it ones, right? So you get 1, and this is its 16, right? So you have 16. So 9 times 1 is 9. And 16 is pretty much A times 16, right? And A, we know A is 10, right? So let me just copy this over. Right, then you can see it. Right, A is 10 right here. So that means 10 times 1 is 6, right? 1 has 60. So 1 has 60 plus 9, that's why you have 169. So that's why the sum, when you convert back, it's always back to 169. But it's actually equal to A9 hexadecimal. Good. So that means if I been given hexadecimal number, convert back to decimal, I just do the exponents like this, right? Which is in exercise 3, you see binary to decimal to binary. We pretty much do this. The decimal to binary, no. Binary to decimal, we do this, right? But let's look at binary to decimal. Yeah, we do this, right? Now decimal to binary is we just divide by 2 and keep the remainders. Keep track of the remainders. Okay, let's talk about we talk about that one. Okay, let's highlight it. Now binary to hexadecimal, we just talk about just now. Right, split in every 4 bits, and you can look up the table here, right? And you can watch the previous video for exercise 1. We talk about that, binary to hexadecimal. Now hexa to binary should be very similar. Like each digit is 5. 5 is pretty much just 0101, right? So like in this case, I pretty much just get 4 is what? 0100, right? From here, right? 4 is 0100 and 5 0101 and 0101. That's how you convert it. Let's do again. FA is what? 1111 and A is 1010. So it's gonna be what? 1111 and 1010. Okay, so you can do the rest. Now decimal to hex, you just need to divide by 16. We talk about this. Now hex to decimal, we just talk about just now. Right, 16 to 0, 16 to 1, right? That's how we do hex to decimal. For example, 5a pretty much as 5 times 16, right? Because 16 to the 1. And then you add with 5 times, no, a times 0. 2 to the 0 is 1, right? Which is equals to what? 5, 6 is 30, 80 plus 10, right? Because a is 10. So it's 90. That's the answer for that one. Alright, the rest should be good. So next video we show